One of the most notable examples of significant figures is found in the calorimetry lab in chemistry. Calorimetry is a measure of heat transfer from one object to another. The reason why significant figures are so important in this lab is because the numbers on the thermometer do not vary much, and it is important to be accurate when taking readings from them. Usually this comes into play with specific heat, such as the problem I've drawn on the screen. Because these numbers all have different amounts before and after the decimal point, we will need to use significant figures. Do not calculate your significant figures until you have finished with calculating the specific heat of the metal. To calculate the significant figures, determine how many significant figures were in the problem to begin with. Then determine how many are needed to be shown. As mentioned in the sig fig rules video before, any zeros before a non-zero number will be classified as non-significant, and any non-zero number is always significant. To calculate specific heat, we will take these four numbers here and subtract the final temperature, which is this one, and the initial temperature, which is this one, using the equation delta T, which was essentially the final minus the initial. And that'll lead us here to an answer of 0.2, which means there's one significant figure. These other two numbers are irrelevant because this is the initial one and this is the final. Mentioned at the start of the video, the Michael Phelps record is one of the most recognized uses of significant figures. There are many other examples that I will touch on too, such as crowd sizes, distance, and time. Crowd sizes always vary. For example, if a stadium seems full but you're uncertain of the fact that it is full, you would use significant figures. Say the stadium was supposedly sold out and held 25,000 people, but did every person come to that event? There would be no way of telling that exactly, and that is where significant figures come into play. The actual crowd size was actually 24,651 or 25,125 with staff working. To make this more manageable, people would would say there's probably 25,000 people there because they were certain that number was being closest to 25,000. This number would only have two significant figures because we are only certain of the 2 and the 5 and 25,000, not the numbers coming after. When it comes to distances, these numbers are exact and not estimated. So when there's a distance of 250 miles, there are only 3 significant figures. This is because we are certain the mileage is 250 miles, and we know it is not guessed. Therefore, we would only need 3 significant figures. In another example, with 300 miles, it is still the same answer of 3 significant figures. The zeros are significant because we know that it is exact. Time can vary just the same as crowd sizes, but it can also be exact as well. With time, we can say it was only 20 minutes, or we can say it will take about 20 minutes. These are how we can take both types of significant figures away from this example. Because there was the guess of about 20 minutes, we don't know if it was 15 to 25 minutes. So the only number we are certain about is the 2 and the 20. So that means there's only one significant figure. But, for example, if we said it was only 15 minutes, meaning we knew it was exact, we used 2 significant figures, one for the 1 and one for the 5.